Hello, we are Team Wuhan Clan of the design class of Fall 2020. Today we are presenting our solution to a major economic problem occurring in the COVID-19 pandemic.
These wells seen in the picture to the right are used on oil, gas, and chemical plants.
Here is a diagram of these wells.
These wells are observation wells and are used to observe any leaks. They are placed next to pipelines, so when a pipeline leak occurs, the product travels into the well water through holes in the well's siding. The product then evaporates and moves to the top of the well and stays there due to the wells being plugged at the top. Currently, the EPA requires the wells to undergo regular gas combustibility tests. These tests are conducted by outside environmental consulting companies. During COVID, these consulting companies are not allowed on plant sites due to social distancing and fear that workers would spread it to each other. Since these consulting companies are not allowed on plant sites, the regulatory combustibility test cannot occur. The device used to conduct these tests is a photo-ionization detector, or PID for short. Current models are seen in the picture here on the slide.
We have designed an autonomous leak sensor that can be left in testing wells for extended periods of time without any outside interaction.
Here is a diagram of an average test well. The PID will sit here.
The sensor will automatically check for leaks and report via wireless communication that it is clear or has found a leak.
A closer view shows here how the PID is connected to low voltage solar panels shown in yellow and a wireless data transmitter as shown in blue. The PID is then connected through metal cables shown in green, which hook to already existing J-plugs that reside at the top of each well.
As it does not need site visits regularly by humans, the monitoring can continue during a pandemic, allowing production to continue uninterrupted.
According to our stakeholder, the average yearly cost to monitor 10 wells per week is estimated at $80,000 per year. This is because the rates for necessary personnel and equipment to test each well in person are high.
Our team estimated that our device will cost the company $17,100 a year, a 78% reduction in price.
This device will also mitigate the costs incurred by pipeline leakage. For an average pipeline, an average leak spills around 7,600 gallons per day, and the average fine per gallon of spillage is around $102. Without this device, it can take roughly 4 days for the leak to be detected. Over these 4 days, the spill would incur around $3.1 million in fines. Our device aims to detect the leak within the first day of a spill, which would significantly reduce the amount of fines incurred.
The gas sensor we are using is able to detect concentration levels in between 200 and 10,000, which covers the hazardous threshold limit for the methane at 1,000 ppm. To test this, we used some natural gas and got the data logged as it can be seen from this video. Our prototype system is able to detect concentration levels of methane with adequate sensitivity, and our production system would be able to detect down to 0 ppm volume.
In conclusion, our product allows for oil and chemical plants to continue production unhindered during a pandemic, and for use outside of a pandemic, allowing companies to have real-time gas detection systems across their plants, preventing major environmental damage and cutting huge costs.